Let's now shift our attention towards Azure Load Balancer technologies, and as you may be aware, these have gone through a lot of iterations in the Azure platform. To set the stage, just remember you may have third-party load balancers that you've used on premises typically, things like F5 as an example. You can still use third-party services in Azure, but Microsoft really wants you to understand all of the native services that they have available for you, and there's a rich set of services there now. To begin with, let's look at the different categories and where they might be used. Well, to begin with, we have our basic and now standard load balancer. Generally speaking, most customers are moving towards the standard load balancer as encouraged by Microsoft in the design. This is your standard load balancer for just balancing traffic, say perhaps across a couple of virtual machines. This can be public or private, as you'll see when we dig deeper into it. We then have the application gateway. This is more for balancing web traffic and provides a whole bunch of advanced features like URL routing and the ability to put on a web application firewall as well. And last but not least, if we have globally distributed applications and we want to do more sort of DNS traffic management and load balancing, then we can use Traffic Manager there, Azure Traffic Manager, to really sort of separate our traffic across regions. Perhaps, you're accessing a website and you're coming from the UK, then maybe it redirects you to a server in Europe. Perhaps you're in the US, then perhaps it sends you to a US server, basically. Well, with that, let's look at the key features of the basic load balancer first of all. Well, for one, this is layer 4 of the OSI model, so that's as far as it goes. It does not work at layer 7, where you'll need the app gateway for that. It supports up to 100 instances behind it. That's the maximum available there on the basic load balancer. It also has a feature called service monitoring, and this basically allows us to have probes that can probe the health of instances behind the load balancer, and then say when the probe doesn't respond, it can stop sending connections to that particular node. Perhaps one of the virtual machines hosting a website's gone down. Well, the probe would respond and say, okay, I can't get anything back from this machine, so I can take action and remove it from the pool. It also then supports automatic reconfiguration. So this is where the load balancer instantly reconfigures itself when you scale instances up or down. So for example, add in or removing VMs from the backend pool or reconfigure the load balancer without you having to take any additional operations on the load balancer resource itself. By default, you need to be aware of the hash-based distribution. So the load balancer uses a 5-tuple hash, and that's composed of the source IP address, source port, destination IP address, destination port, and IP protocol number to map flows to the available servers. You can change that to a 2 or 3 tuple hash for a given rule if you want to. You may have scenarios where you need to do that, but by default, know that it is a 5-tuple hash that's in play there. Last but not least, I did mention internal and public options are available for the load balancer. So you can use it and attach it to a public IP address. So for traffic coming into Azure through the web, you could do it that way. Or if you just want to balance, load balance internal services, that's not a problem as well. With that, we now need to move on to our standard load balancer. Remember, we were talking about the basic one, and this one really builds upon those features. So assume, and we do cover a table later on, but assume all the main features are there. There's a lot of enhancements with the standard load balance, and it's pretty much the way to go now, as I said before. So layer 4 still, that's something just to keep in mind to begin with. It's still a layer 4 load balancer, but it supports up to 1,000 instances as opposed to the 100 on the basic load balancer. Any virtual machine in a single VNet. This is a big difference because in the basic load balancer, we tie it to an availability set, and this works with blended options as well, so VMs and other services in that same VNet. So that's a big difference there as opposed to being tied to that availability set. It supports HTTPS as well, whereas the basic load balancer just supports HTTP and TCP, so a big change there. And it also supports availability zones, so much more from an availability perspective here. When you're in a region and you want to separate out between multiple availability zones, the good thing is the load balancer is also highly available across those zones. And last but not least, it's secure by default. One of the big contrasting features with the basic one, when you deploy it, is open by default, whereas the standard load balancer is secure by default, and then you have to make the changes to unlock the pieces that you want to do. Now let's take a look at some examples of how these internal load balancers work. And this might be repetitive if you're coming from on-premises, but just to reinforce for anyone brand new to load balancing, when we look at an internal example, we'll deploy the internal load balancer, as you can see on screen now highlighted. That's our internal load balancer with a private IP assigned to it. So it has its own IP address assigned to the load balancer, and we can basically send traffic to that IP address. It will then forward the traffic on to one of the two database servers. In this example, these are two virtual machines that are in that, say, virtual network and tied to this load balancer again. If we were on a basic load balancer, they would have to be in an availability set. If we're using the standard load balancer, then they can just be in the virtual network and they can use the standard load balancer. But traffic comes into the ILB and then gets, spread out between DB1 and DB2 in this example. Then we have our public example as well. So now we've got traffic coming in through the internet, through, say, TCP port 80, hits the load balancer. Again, this is a load balancer on a public IP address now, and then that's going to forward traffic on through port 80 again, because it's coming through port 80 there, to these three web servers in this example here. Moving on, we have a multi-tier example where we mix in and match in a little bit. So perhaps we have our public load balancer first of all at the top, and then our internal load balancer at the bottom. So you can see traffic comes in at port 80 over the web, hits our public load balancer. That traffic then gets spread out between the three virtual machines we've got there. These will typically be web servers. In this example, we've got a web tier subnet here created for these machines. And then those machines will then also use a load balancer, now the internal one on the bottom, to hit their respective database servers. So the database traffic will be, spread out amongst those servers. Obviously, there would need to be something in place to make sure that the data is all synchronized between those SQL servers on the bottom. But essentially, that traffic comes through the web tier and, it's load balanced at that level and then load balanced again as we hit the database as well. Now let's look at the standard versus basic ALB, and this slide is included in the course material, so I encourage you to read through it as well as some of the links in the study guide. But just to kind of hit some of the key things again here. One, the standard SKU and the basic SKU. The standard one supports 1,000 instances, the basic one is 100. The backend pull endpoints, again, any virtual machine in a single virtual network, including, like I mentioned, blending before, of virtual machines, availability sets, virtual machine scale sets, as opposed to the basic SKU, which is really tied to that availability set or a virtual machine scale set as well. The health probes apply to HTTPS as well as TCP and HTTP. And you can see the health probe down behavior is different as well. TCP connections stay alive on instance probe down and on all probes down. On the basic SKU, TCP connections stay alive on instance probe down. All TCP connections terminate on all probes, or when all probes are down. Availability zones then, again, only supported in the standard SKU, and same with HA ports there. You can see they're only supported in the standard SKU for the internal load balancer. You do have some other things like advanced diagnostics, secure by default, as I mentioned, and some differences around outbound connections there that I encourage you to read about as well. And just to reinforce the load balancer scope, I mentioned it there, but know this is a key part for many of the exams. While the basic load balancer is scoped to an availability set, the standard load balancer is scoped to the entire virtual network. Just can't stress that enough. Make sure you understand that, going into the exams. Well, let's turn our attention now to the App Gateway, and the Azure Application Gateway is a web traffic load balancer. So this operates at layer 7, and this enables us to manage traffic to our web applications. So again, the traditional load balancers operate at the transport layer, that's OSI layer 4 for TCP and UDP, and they route traffic based on source IP address and port to a destination IP address and port. In contrast with the App Gateway, we can now make routing decisions based on additional attributes of an HTTP request that's coming in. It includes some features like cookie-based session affinity, so we can have sticky sessions if we want to. We can make sure that somebody coming in with their browser hits the same website every time while they're in that particular session. Perhaps they checking out something from a shopping cart or something, buying something online. Those are some of the good features that we have there. It supports SSL offload, so all that encryption that we want to do. We don't have to do it on the web server itself now and consume CPU cycles there. We can offload that to the app gateway as well, and let the CPU that's associated with the app gateway take care of that for us. Supports end-to-end SSL. It supports web application firewall, so there's multiple SKUs available to you in App Gateway, and you'll see some of this in the demonstration that follows as well. But the web application firewall, this allows us to turn on extra security, so SQL injection, cross-site scripting, things like that. Those can be turned on and gives us a much more secure application by using the web application firewall feature. But again, there is a cost for that, and you have to turn that on when you deploy your app gateway or upgrade your SKU to it later on as well. The next thing is URL-based content routing. So I mentioned with the app gateway, you can make these routing decisions based on additional attributes of the HTTP request coming in. And URL is a good example here, and we'll talk more about that in a minute. One thing to note, it does require its own subnet. So you create a subnet for the app gateway first of all, and you put it in there, and then you forward traffic onto the other subnets. And then it's also highly available as well and supports availability zones also. So highly secure, highly available, great product, especially the version 2 when they released that, it's made things much better, performs very well. If we look at the app gateway architecture, and look here from say you're the user on the left, you're coming in with your browser, you come into your app gateway front end, whatever IP you've associated there, you've got this HTTP, HTTPS listener on there, and then you have a whole bunch of rules basically that you associate with it, and that could say direct traffic to a certain set of VMs or a scale set or on-prem servers. You've got a lot of flexibility there in the rules and the HTTP settings that you configure. Now let's talk about that URL-based routing, and this really should explain it to you. If you've got a user coming in, let's say Contoso.com as the example here from Microsoft, they hit the app gateway, we've got that web application firewall, so we've got additional security there as well, but we're hitting that layer 7 load balancer once we've passed all the security checks. And now, depending on the URL, let's say that they're going to /images for something, we might have a pool of servers that just serve up images, and perhaps we've got a URL /video /something. It's going to go to the video server pool there. So this allows us to sort of scale our backend infrastructure based on the requests coming in and mix and match what we need to ultimately give that user a really good experience, and that's all based on that URI content filtering that's available to you. App gateways do have sizes, so based on the page response, whether it's 6K or 100K, small, medium, large, these are the throughputs that you can basically expect to get, and this table again is in the attached PowerPoint slides for you. Key things just look out for, big difference between 6K and 100K, so watch out for that. You're probably not going to really use the small in a lot of occasions for enterprise workloads, so when you sort of get questions around this in terms of specs, just watch out. You're probably going to be in the medium and the large for a lot of the examples that Microsoft gives you. Load balancer comparison, just going back and kind of revisiting, we've covered a lot here from the basic to the standard. We talked briefly about Traffic Manager, which you just need to be aware of, and we've talked a lot about App Gateway now. But just keep in mind, first of all, so the technology, the transport layer, it's layer 4 for load balancer, layer 7 for App Gateway. Traffic Manager is DNS level traffic management there. Application protocol supported, so any in load balancer. App Gateway is really around HTTP, HTTPS, and WebSockets. It's really aimed at web applications. Traffic Manager again is any. The Azure Load Balancer, the endpoints, so Azure VMs and cloud services role instances, but you've also got with the standard load balancer now, remember it's VNet bound, and so you can mix and match services in there if you want to, virtual machine scale sets, etc. App Gateway endpoints can be any Azure internal IP address, public internet IP address, Azure VM or Azure Cloud Services, and Traffic Manager is Azure VMs, Cloud Services, web apps, and external endpoints as well. It's a big difference there. VNet support, so you can see, can be used for both internet-facing and internal VNet applications on the Azure Load Balancer. App Gateway can be used for both internet-facing and internal VNet applications as well. Traffic Manager, however, only supports internet-facing applications. Endpoint monitoring, you've got probes in the gateway and the load balancer, and then you've got some HTTP, HTTPS GET monitoring support in the Traffic Manager. So a lot of options there. Again, keep in mind with the load balancer, you're probably going to be using the standard 99% of the time now. It's secure by default, supports a lot more options for us, more available, better performance, etc. App Gateway, web applications, know when and when you don't need the web application firewall. Traffic Manager, think region-based load balance in there. And with that, that concludes this lecture, and I encourage you to follow through on the demos that follow. They should hopefully hit home how to configure some of these things and how they work in practice.